Hello, welcome back. We're going to continue our discussion with the triple integral. More importantly, how we can rearrange the order of our three variables to find the volume. And we're looking for the volume here. Remember, dv is just the combination of how we can rearrange our variables. In this case, dy, dx, dz, or could I go dz, dx, dy? And there are 6 possible ways. Now, in the previous video, we said we're going to do dz first, and we did the dy, dx, dz, dx, dy. They're pretty easy to find. We also did, well, what happens if we do dy first? And we get dy, dx, dz, dy, dz, dx. And again, they're pretty easy to find. But for this video, we're gonna shake it up a notch. And we're going to do dx first. And this one's a little bit trickier. If we're doing dx first, remember, our yz is going to plane, that's going to be our base. Now again, we're going to have 2 options here. Option 1, we can do dx, dy, dz, or we can do dx, dz, dy. Remember, these 2 right here are going to form the base. So our base is going to be on the yz plane. This is going to give us our height. And you multiply those together, that's how we're going to get our volume right here. And that's this v equals dv bit right there. So let's take a look here. So for the first one, let's get ready to rumble. We're going to use dx, dy, dz. Now this one's a little bit trickier here, so I'm actually going to graph the entire image that we're looking at so we can kind of see it better. So I'm going to use a 3-dimensional graph here, x, y, and z. So, because if I want to find my limits, which is what we're looking here, I have to be careful, especially with the y value, because I have a variable with the y. Anytime I'm changing the variables, we got to pay attention. So, I'm going to graph this. So, my x's go from 0 to 2. My y values are going to go, or my z values, excuse me, are going to go from 0 to 3. But remember, from the first example, when we graphed it, our change in y is a parabola. Y goes from x squared to 4. We saw that in our first one. So I'm going to graph it down here. This is y equals x squared from 0 to 4. So this is the base reach. This is the floor of our graph. But remember, the xy plane is the yz plane is my base this time. So if I were to, this is just a parabolic cylinder. We can kind of see that right here. Missed it? There we go. So what we wind up with is a parabolic cylinder, and we want to find this volume. So to do this, first thing we're going to do is we have to find the change in our height. That's our dx this time. So that's our height. Our height is first. That's the first one, delta x. And be careful. We measure the height from the function, the surface, to the base. So that's how we're going to get the height. Okay? It's going to be the base to the surface. So if I pick any point on the surface, I'm going to go really easy. I'm going to be really lazy. I'm going to pick a point down here. There we go. My minimum x value there is 0. My maximum x value, I have to go to the surface. And that's going to be right over here. So this right here is my maximum x value. Now you might be thinking it's 2, but that's only if it's at y equals 4. Be careful. When I write this stuff, my maximum x value, we have to switch our variables. And we saw from the first example, we just wrote that as y equals x squared. Remember, it's y equals square root of y. X equals square root of y. Oh wait, I got it out right this time. We saw that right over here. So that's going to be my maximum x value. Square root of y. That's the second time I've done that. 4th time in the video, that's the 3rd time I've done that. Alright, so now we're going to talk about the base. Remember, our base is the yz plane. So we want to do dy first, so change in y first. So it's a rectangle. So if I want to change in y first, I'm going to do a rectangle going along parallel to the y-axis. My minimum y is 0, my maximum y is 4. And then I can get the change in z. Right? This rectangle is going to go up and down from 0 to 3. And I can write my integral. My change in x, 0 to root y. My change in y, 0 to 4. My change in z, 0 to 3. and this will find us our volume. Now, the other option we had, we can do dx, dz, dy. So again, I'm going to graph it out. Let's take a look at it. Same graph, 2, 3, 4. There's my parabola. Oh, this looks much better already. There's my cylinder. Silly cylinder. Oh man, I messed it up again. Oh well. Ta-da! There we go. A miracle happens. Okay, so there we go. All right. Next, first things first, to get the limits. Again, because I'm doing dx first, that's my height. And its base, the change in x, my height here, the change in x, starting at the bottom here, my minimum x is 0, and we're going to go to the surface, which again, remember, is x equals root y. You have to switch your variables here because we're changing x, we have to look at the y, how it relates to the change in the y value there. So next, we got to get the base. Well, remember, the base here again is now the zy plane. I guess you can say it that way, right? So we want the change in z to go first. Well, there's my z-axis. So I'm going to do a rectangle parallel to the z-axis. So my change in z's goes from 0 to 3, and then I got my change in y's. This is going to go from 0 all the way to 4. Now, some of you guys might be recognizing there's a little pattern here. We'll talk about that. This goes from 0 to root y, 0 to 3, and 0 to 4. Now, some of you guys kind of maybe recognize something here. If we have a rectangular base, it's really not that hard to do. You can just switch your variables around. So if you have a rectangular base, you can just switch the order easily. Okay? But if it's not a rectangular base, like it's a surface like this, you just can't switch them, so you got to be really careful with these. All right, hope you guys enjoyed the video. I will see you all later. Bye-bye.